Cryptography, a presentation by Malcolm Anderson. What is cryptography? Cryptography is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. Cryptography includes techniques such as microdots, merging words with images, and other ways to hide information in storage or transit. Cryptography prior to the modern age was effectively synonymous with encryption, the conversion of information from a readable state to apparent nonsense. The originator of encrypted message, Alice, shares the decoding technique needed to recover the original information only with intended recipients, Bob, thereby precluding unwanted persons, Eve, from doing the same. However, in today's computer-centric world, cryptography is most often associated with scrambling plain text into ciphertext, a process called encryption, then back again, known as decryption. Cryptography concerns itself with the following four objectives. Confidentiality. The information cannot be understood by anyone for whom it was unintended. Integrity. The information cannot be altered in storage or transit between sender and intended receiver without the alteration being detected. Non-repudiation. The creator of the information cannot deny at a later stage his or her intentions in the creation or transmission of the information. Authentication. The sender and receiver can confirm each other's identity and the origin of information. History of cryptography. Cryptography is derived from the Greek word kryptos, meaning hidden. The origin of cryptography is usually dated from about 2000 BC with the Egyptian practice of hieroglyphics. These consisted of complex pictograms, the full meaning of which was only known to an elite few. The first known use of modern cipher was by Julius Caesar, who did not trust his messengers when communicating with his governors and officers. For this reason, he created a system in which each character in his messages was replaced by a character three positions ahead of it in the Roman alphabet. In cryptography, plaintext is information a sender wishes to transmit to a receiver. Before the computer era, plaintext most commonly meant message text in the language of the communicating parties. Since computers became commonly available, the definition has expanded to include messages, for examples, emails, document content such as word processor and spreadsheet files, audio and video files, digital photographs and other multimedia, files containing other files such as zip files or ISO images, ATM, credit card and other banking information, sensor data, and any other data that a person wishes to keep private. Much of this data is not directly meaningful to humans, being already transformed into computer manipulated forms. While the original definition implied that the message could be read by a human being, the modern definition emphasizes that a person using a computer could easily interpret the data. Ciphertext is the result of encryption performed on plain text using an algorithm called a cipher. Ciphertext is also known as encrypted or encoded information because it contains a form of the original plain text that is unreadable by a human or computer without the proper cipher to decrypt it. Ciphertext has two different types of ciphers, which are substitution ciphers and transportation ciphers. A substitution cipher is a method of encoding by which units of plaintext are replaced with ciphertext according to a fixed system. The units may be single letters, the most common, pairs of letters, triplets of letters, or mixtures of the above, and so forth. The receiver deciphers the text by performing the inverse substitution. An example of substitution cipher is shown below. Transportation cipher is a method of encryption by which the positions held by units of plaintext, which are commonly characters or groups of characters, are shifted according to a regular system so that the ciphertext constitutes a permutation of the plaintext. That is, the order of the units is changed. An example of transportation cipher is shown below. There are two basic techniques for encrypting information: symmetric encryption, also called secret key encryption, and asymmetric encryption, also called public key encryption. Symmetric key encryption is the oldest and best known technique. A secret key, which can be a number, a word, or just a string of random letters, is applied to the text of a message to change the content in a particular way. This might be as simple as shifting each letter by a number of places in the alphabet. As long as both senders and recipient know the secret key, they can encrypt and decrypt all messages that use this key. The problem with secret keys is exchanging them over the internet or a large network while preventing them from falling into the wrong hands. Anyone knows the secret key can decrypt the message. One answer is asymmetric encryption, in which they are two related keys, a key pair. A public key is made freely available to anyone who may want to send you a message. A second, private key is kept secret so that only you know it. Any message, text, binary, files, or documents that are encrypted by using a public key can only be decrypted by applying the same algorithm, but by using the matching private key. Any message that is encrypted by using the private key can only be decrypted by using the matching public key. This means that you do not have to worry about passing public keys over the internet. The problem with asymmetric encryption, however, is that it's slower than symmetric encryption. It requires far more processing power to both encrypt and decrypt the content of the message. Pros and cons of data encryption. The pros are separation. Data encryption allows the data to remain separate from the device security where it is stored. Security is included with the encryption, which permits administrators to store and transmit data via unsecured means. Data breach prevention. Data encryption circumvents the potential complications that accompany data breaches, which provide ensured protection of intellectual property and other similar types of data. Encryption is on the data. Because the encryption is on the data itself, the data is secure regardless of how it is transmitted. An exception to the rule can be transmission tools such as email, because sometimes a typical email account does not provide the necessary security. Encryption equals confidentiality. A lot of organizations are required to meet specific confidentiality requirements and other associated regulations. Encryption data means that it can only be read by a recipient who has the key to opening the data. The cons. Encryption keys. Without a doubt, data encryption is a monumental task for an IT specialist. The more data encryption keys there are, the more difficult IT administrative tasks for maintaining all the keys can be. If you lose the key to the encryption, you have lost the data associated with it. Expense. Data encryption can prove to be quite costly because the systems that maintain data encryption must have capacity and upgrades to perform such tasks. Without capable systems, the reduction of system operations can be significantly compromised. Unrealistic requirements. If an organization does not understand some of the restraints imposed by data encryption technology, it is easy to set unrealistic standards and requirements which could jeopardize data encryption security. Compatibility. Data encryption technology can be tricky when you are layering it with existing programs and applications. This can negatively impact routine operations within the system.